Hey guys, welcome. My name is Rachel and you're watching Rachel Teaches Math. Today we're going to be covering the differences between linear, quadratic, and exponential functions. So when you're getting into your real heart of algebra lessons, quadratics are king. So I'm going to start with the two that you already know, linear and exponential. So in a linear function, you're just looking to find what is that constant rate of change. So in this table, I'm looking to see, okay, how do I get from -1 to 1? Well, that is an increase of 2. That would lead me to believe that my slope or my rise over rho would be up 2 over 1. Let's confirm. In math, you always check 3 times to make a pattern. From 1 to 3, you're increasing by 2. From 3 to 5, you're increasing by 2. We can kind of assume that it's going to continue in this pattern. And then just check that you do have a constant rate of change on the left side of your table. Check your x values. From -1 to 0, you are adding 1. From 0 to 1, you're adding 1. And then from 1 to 2, you're adding 1. So that's great. That means we have a slope of 2 over 1, up 2 over 1, or you can also go the other direction, which is -2 over -1. My y-intercept is a super important coordinate from this table. So anytime x equals 0, you just found where your function is crossing the y-axis. And that will be for any functions from now until the rest of your math career. So I'm going to start at 1, and then from there I'm going to go up 2 over 1, up 2 over 1. And like I said, you can also go the other direction. So for my y-intercept, you can also go down 2, back 1, down 2, back 1. So I'm not going to go too much into linear, but if you put it together into an explicit rule, y equals mx plus b, and explicit is just a fancy way of saying that it is solved for y and it's ready to go into your graphing calculator. My rule would be y equals 2x, and then my y-intercept was 1, so plus 1. All right, going on to exponential, just very quickly, this should be a little bit of a review. My pattern from 1 to 2, remember that exponential is a pattern of multiplying by a whole number or fraction. So from 1 to 2, I do have a pattern of times 2. From 2 to 4, times 2, 4 to 8, times 2, and this pattern does continue. 8 to 16 is times 2. I did not choose complicated linear and exponential patterns because I just want you to see that there's a little bit of a difference between the way they look graphically and how the equations look. So this just means that each time for every x, you are doubling for y. My equation is going to be written in the form y equals a times b to the x. It's kind of confusing because the b in this is not the same as the b in this. This means your a value, which is your starting value or your y-intercept, times your pattern or common ratio raised to a variable. So my a value is going to be 1, so I'm still starting at 1 on this, okay? And then my pattern is times 2. So my final equation would be y equals 1 times 2 to the x, or just 2 to the x. So my next point would be over 1 up 2, or sorry, not over 1, over 1 up 2, and then over 2 up 4. I'm just getting it from the table. Over 3 up 8, 3. And that's really all I'm going to be able to fit in this table. But it would end up approaching the x-axis really close and then begin to curve up and grow very quickly. An exponential function grows really quickly. Now, quadratic, this is brand new for you guys. If you're just starting algebra, this is by far my favorite. It's interesting, it's symmetrical, I think it's beautiful, and it's a little bit more fun to find the pattern in a quadratic. So I want you to look at the y values first. To get from 1 to 0, think, what do I have to do? Am I increasing or decreasing? Well, in this case, that is a pattern of -1. Okay, well now I'm going from 0 to 1, so it kind of switches here. I'm going +1. What's going on? From 1 to 4, I'm adding 3 now. And then from 4 to 9, I'm adding 5. Well, that's definitely not linear, because it's not adding the same number, and it's definitely not exponential because I'm not multiplying. So the interesting thing with a quadratic is that this first difference is essentially the pattern that you see initially. And then you have what's called a second difference. So we're going to do the same thing again. To get from -1 to 1, your increase is +2. To get from 1 to 3, your increase is plus 2. And to get from 3 to 5, your increase is plus 2. So the most important thing with a quadratic is that you have to find 2 sets of differences. Your second difference should be a constant change. So your first difference is actually linear if I were to graph it. Your second difference has to be the same number, okay, or we could just say it's constant. So I know, I've checked, this is quadratic. What I'm going to do now is just try to graph it and kind of show you what it looks like. So I know that it's crossing at 0, 1. They all have the same y-intercept. Now, I'm going 1, 4, so over 1 and then up 4. 2, 9, so over 2 and then up 9. And the cool thing about a quadratic is that it has vertical symmetry. So that means that everything that's on the right side of my function will also happen on the left. So now I have negative 1, 0, negative 2, 1, and you can see it's starting to kind of turn around here. So I know that my next point is going to be up 3 and then to the left 1, and then up 5 and to the left 1. And we're going to get more into that graphing of quadratics and writing the equations for quadratics in future videos. All I need you to know right now is that in a quadratic, your first difference is linear, RPIs, and your second difference is constant. Okay, and then if I were to connect them, here's this beautiful curved kind of U-shaped graph, and that is it. Thank you.